Hello, good afternoon. Welcome to Running Linux on Hyper-V and in Azure. My name is Anurag. I'm a program manager on Microsoft's Open Source Technology Center. So we're directly in Windows Server, and we work on the Linux drivers for Hyper-V, running Linux in Azure, as well as Linux and Unix management with System Center and Operations Management Suite. So today I'm going to go over kind of the product goals, what we hope to accomplish with Linux and Hyper-V and in Azure, kind of a brief overview, what does Microsoft and Linux look like, what does that entail, then a little deeper dive in Hyper-V, what Linux integration services are, how you can maximize your Linux and Hyper-V deployments, as well as Linux and Azure, kind of a brief overview there and what that ecosystem looks like as well. So Microsoft loves Linux. I hope you guys have seen this slide. Last October, our CEO, Satya Nadella, came out and had this slide, and us in the Open Source Technology Center adopted it as our motto, our mantra, our logo. In fact, so much so that I actually have stickers and buttons here with this exact message printed on it that I hope you guys will come up here afterwards and take. Probably surprise some of the Linux admins you guys are working with, surprise some of the Windows guys. Overall, this is now a fundamental piece of what we're doing. And you know, a lot of questions is, hey, why does Microsoft love Linux? You know, why all the love all of a sudden? And the truth is, Linux is a real business for Microsoft. You know, 20% of IaaS VMs in Azure are running Linux. That number's actually grown to 25%. Mark Russinovich, our CTO, announced that about a month ago. And so we're continuing to see an increase of Linux and IaaS, and it's definitely an important piece. And then System Center. System Center enables management of numerous servers, Linux, Unix, and Windows, and we're seeing hundreds of thousands of Unix and Linux management servers there. And then a lot of enterprises and hosters are running Linux as a guest on Hyper-V, and we want to make sure that that's going to be the best experience possible. And while the message may have came last October, we've been at this for a while. 2009, we released System Center management capabilities for Unix and Linux. That development began in 2007. And then Linux drivers have been available for Hyper-V since 2010. You might remember, hey, pigs are flying. Microsoft is committing to the Linux kernel. In fact, we are one of the top 10 contributors to the kernel. And then Azure IaaS, Linux VMs have been running there day one since 2013. Right when you had Windows, Linux was right there beside it. So now Linux and open source are a fundamental part of what we do, so much so that my team name has Open Source Technology Center. So just a kind of brief overview of what the ecosystem looks like. There's a bunch of check marks here, so many products listed. Just a brief overview. We're aiming at the enterprise Linuxes. You have Red Hat, SUSE, CentOS, Ubuntu, Debian. And we've done a pretty good job of filling in all the check marks there in the System Center management space, as well as the Hyper-V and Azure IaaS. And so you'll notice there's a couple of check marks missing there, but that's not due to any technical limitations. More to come as we continue. So goals for Linux support. We want to make sure you guys are having the best experience for running Linux on Hyper-V and Azure. The experience when we started off was kind of there just to start it and get you going, and now we're kind of moving in the direction of where we're performantly competitive, where we're bringing real features and real solution sets into the space. We want to make sure we're providing great choice and flexibility in running Linux distributions. From all the ecosystem Linux distributions we saw, we're making sure we're keeping up to date with all the latest versions. So Red Hat 7.2 is coming out soon. We're working with Red Hat directly there. We have Debian 8.2 came out and Ubuntu 15.04. So we're making sure that we're staying up to date with the latest and greatest versions. You're not going to kind of hope, hey, is Hyper-V able to run the newest, latest, and greatest? And lastly, we want customers to be able to easily deploy and manage their Linux workloads in Hyper-V and Azure. We want to make sure this is a seamless experience. You're not messing around trying to figure out where that additional option for Linux is. It's going to be there side by side with Windows. It's going to be a first-class citizen. So Linux and FreeBSD and Hyper-V. So just a quick show of hands. Who here is running Hyper-V today? Okay. And keep your hands up. How many of you guys have Linux in your environments? Okay, same number. Good, good, good. Good that you're here. How about FreeBSD? Anyone have FreeBSD in their enterprise today? That's okay. Oh, we have one over here. Good. There's one slide just for you. So when we talk about the universe of Hyper-V functionality, there's two main spheres. We have outside the guest, and we have guest cooperation needed. And so outside the guest, you're going to have rapid live migration with RDMA, software-defined networking, software-defined storage, storage quality of service. And the piece there is it all works for Linux and FreeBSD. Our developers now are making sure that when they go out and build these capabilities for outside the guest, that Linux is also taken into consideration. How is this going to work on Linux? How is this going to translate in an enterprise environment running more Linux than Windows? And so this is going to be covered by mainly other sessions. For this session, I'm going to be focusing on what cooperation the guest needs with the Hyper-V host. And this is going to have features like enhanced management, dynamic memory, live backup, and then generation 2 VMs as well. So that will be for this session. So running a guest OS on Hyper-V, what can I run? Can I run AIX? Can I run Solaris Spark? So let's start off with this nice little flow chart, and we'll say, hey, does it run on x86 or x64? If the answer is no, it's not going to run on Hyper-V. So the answer to AIX, Solaris Spark, dead end, not going to happen. And the thing to note here is that's not competitively disadvantaged. VMware isn't doing AIX or Solaris Spark, catering mainly to x86 and x64. So if yes, we have to ask the question, do we have integration services? So we'll dive a little deeper into what integration services are in a little bit, but just as in a nutshell, they're device drivers that give you kind of the best performance, bare metal, near bare metal performance as well. And so if you don't have it, you're going to get emulated devices, and you can have limited functionality, limited manageability, okay CPU. You can do it, it works, but unfortunately it's not as fast as you need to be in an enterprise environment. And if it is, yes, you do have integration services, fantastic. You're going to get that great performance that you expect when you run virtualized environments. And of course, that's where we want to be, and that's what we'll talk about. So Linux integration services. So Hyper-V is going to first present synthetic devices to the guest OS as soon as you load it up. And the guest OS is going to say, hey, look at all these devices. I need some drivers to kind of say, hey, what do I do with these devices? And that's where integration services come in. They're the drivers that Hyper-V is going to use to facilitate that connection between the guest OS and the Hyper-V host. And then one thing to note is the synthetic devices are going to be agnostic of the hardware underneath. So if you have Intel or Broadcom as your NIC, doesn't matter. It's going to be the same NIC presented to the Linux VM. And then integration services, of course, aren't going to be shared between Windows, Linux, and FreeBSD. They're going to differ platform to platform. And of course, we have different developers working on each one to make sure that we're providing the best experience for each platform. And lastly, these integration services have a kernel space and a user space daemon, and that allows us to facilitate a lot of the features you might see with the enhanced management, live backup, etc. So how do we go about developing, right? In the most traditional sense, we have Microsoft devs, we have you guys, the customers with Hyper-V. We post it online, and you go out and download it, right? But that's not akin to the Linux development cycle, right? We want to embrace the community, so we've also gone out. We've made sure that we're committing all these changes we need to run Linux as a guest on Hyper-V upstream and get those changes into Linux kernel main. We go through the nice email process that's required there to get the kernel code there. And then we go out to the distribution vendors. We go to Red Hat, Oracle, SLES, and say, hey, guys, can you pull in these changes we've committed upstream into your distribution so our customers, you guys, can run their operating systems as a guest in the best experience possible. And when we talk about support issues, that's going to flow in the opposite direction. If you have an issue with Linux running on Hyper-V, you contact the distributor, and if they find the mistake in Hyper-V, of course, Microsoft will go and fix that. So Linux integration services, LIS and built-in, right? So if we commit those changes upstream and they get picked up, you have the latest and greatest already baked in. You're going to have this great performance as soon as you load up the VM. But what does so if we go out and put it online, what does that mean? Can you update to it? How does all that work? And so the way we've done it is we said, if you go out and download, great, you have LIS, and we'll continue to post them online so we can continue to give you enhanced performance as well as bug fixes. And so LIS is only, this downloadable package is only compatible with Red Hat, CentOS, and Oracle Linux with the Red Hat compatible kernel with the following versions. And you can see that we have the newest LIS 4.0, which we'll talk about in a second. And the other thing that's really important with the support statement from Red Hat is with LIS built in, you're going to get the full support that Red Hat offers, get the full benefits of your Red Hat subscription. And then, the non-LIS downloads, right? Your Ubuntu, your SLES, your Oracle Linux with the unbreakable Linux Enterprise kernel, and then Debian server. These are going to be the guys that you can only get LIS because we work with those guys to make sure the latest and greatest is in that distribution when it's released. So LIS 4.0 package, what's in it? Why do I care? It's the newest version. It succeeds LIS 3.5, which was released around 18 months ago. And the reason you're going to want to upgrade is we give huge performance gains, especially for networking, as well as some bug fixes that were present. And then if you do decide to take your Red Hat and then update to the new LIS package, you should always be cognizant of any supportability statements there with Red Hat and make sure that you're still going to be covered by the subscription. So just a note that you should check before upgrading. And then compatibility, Red Hat, CentOS, and Oracle Linux with Red Hat compatibility. And then a couple of prerequisites there if you're going to install with no LIS, LIS 3.5, with built-in LIS. And then sometimes we see that customers run into issues once they install it. We always say, hey, did you reboot? Sometimes you don't need to reboot Linux servers for years, but if you do get a kernel module, you're going to have to reboot. And then source code, right? We're committing to the Linux kernel. The Linux kernel, of course, is open source. You can go on to the kernel.org, look at the Git tree, look at what's going on there. And then you can also look at GitHub. We've made sure that, hey, for the open source guys who love GitHub, that's up there as well. And then it's also available on the ISO as well. So the following files include all the nitty-gritty stuff that we've committed. And adding on top of this, since I mentioned the last time we had LIS 3.5 was 18 months ago, going forward, we're going to make sure that the cadence of those LIS releases is much faster. We're looking at 3 months versus 18. So FreeBSD and Hyper-V, this is that one slide. Just a quick overview of FreeBSD, not Linux, Unix descendant from Berkeley software distribution. You can't use Unix because it's copyrighted. Someone will get mad, someone will sue. And FreeBSD is the most popular version of BSD variants from OpenBSD, NetBSD, etc. And then we have a whole other development cycle sphere to get it in the BIS tree. And we have BIS built in for 10, and we have ports available for FreeBSD 9 and FreeBSD 8. And then if, Anurag has a weird accent, he's talking too fast, I completely miss what LIS is, I completely miss what's built in. All of this is available on the TechNet documentation and nitty-gritty detail, so you guys can go over there and see kind of what the best practices are, and some great matrices of, hey, do I match this piece to this piece? Can I run LIS or not? And then when we talk about operating Linux VMs in Hyper-V, it's going to be very familiar if you've operated Windows VMs. You can use Hyper-V Manager. You can use the virtual machine connection, see what's going on in your Linux VM. You can use PowerShell. If you're going to start a VM, stop a VM, same PowerShell commandlets. Don't have to do start Linux VM or stop Linux VM. If you're using System Center Virtual Machine Manager with Azure Pack on top, Linux plugs in really well over there as well. FreeBSD, unfortunately, is not available through that medium. And then lastly, the Azure Public Cloud. If you're using the Azure Public Cloud, which of course has Hyper-V as its base layer, you're going to be able to operate Linux and FreeBSD just like you would with Windows. So Linux integration services, these are the nitty-gritty features we offer with LIS. So the first one is going to be enhanced management. What does that mean? So shut down Linux guests from the management console. So if you don't have integration services and you shut down, it's very similar to you taking a server's power cord and just pulling and yanking it. So we make sure that we have the enhanced management there with the user space daemon, and it's going to make sure you have a graceful shutdown so you don't lose data or anything like that. The other one is time sync. So if you stop and resume your VM and you restart, we're going to make sure that the time there is synced, and as well as we have a recommendation for running NTP, just so you don't have any wall clock time drift. I know sometimes I look at VM time and I'm like, I'm not late for the meeting, and then I miss 2 or 3, and here I am. Key value pairs. So the key value pairs allow for bidirectional host and guest communication for some basic info like IP address. It doesn't require network connection, and it can actually be utilized by third-party developers that want to build on top of Hyper-V's APIs. You can push more information, pull more information. That channel is available to you. So Generation 2 VMs and VHDX resize. So these are akin to Windows Server 2012 R2. Generation 2 VMs use UEFI instead of BIOS, trimmed down version, no longer have legacy device emulation, allow you to PXE boot from a network adapter, works with Linux just like it does with Windows. You can do a Gen 2 Ubuntu VM, have a couple running here as well. And then Secure Boot. So Secure Boot, if you've used Hyper-V 2012 R2 and you put a Gen 2 Linux VM and you went and booted up, you might have noticed, oh no, it's not booting correctly. And the reason is Secure Boot is turned on automatically. And Secure Boot looks and says, hey, do I have a rootkit here with this bootloader? Is it signed? Is it authenticated? And the Secure Boot in 2012 R2 with Linux VMs, unfortunately, couldn't verify the certificates. So we worked with all the Linux distributors. We worked in 2016. So now if you have a brand new Linux VM, you have Red Hat 7, and you go out and put that, we'll make sure that you don't have a rootkit, and we won't make you turn off Secure Boot. So that all works in 2016. So VHDX resize. So this is a feature where you can extend how large the volume is, and it happens live. Your Linux VM can actually watch it happen. The only thing is you're going to have to automate the file system also expanding to meet that new disk available. Dynamic memory. So dynamic memory, so Hyper-V, of course, is controlling the memory allocation to your VMs. Dynamic memory allows you to get higher density via memory overcommit. You can have more VMs running on your Hyper-V server. And it works for Windows and Linux running on the same exact Hyper-V host. So you don't have to have a dynamic memory Linux, Hyper-V, and dynamic memory Windows. And there's 2 concepts here. There's hot add and ballooning. So hot add is the concept of I have a big workload, and kind of the memory I already have is no longer sufficient. So I'm going to add additional memory on top. And it sounds straightforward, and the Linux OS is going to say, oh, I have new memory. I'm going to now use it. But the thing is, hot remove has not been implemented. So we can't take away the memory from the Linux VM. And that's where ballooning comes in. And so ballooning says, OK, I'm going to grab some pieces here and here and here from the memory, and I'm going to bring it back to Hyper-V. So the Linux OS doesn't see that its memory has been removed, but Hyper-V under the covers has gone out and taken that memory back and allows it to use it for other guests running on the same system. And say your workload increases again, we can balloon back that memory that was taken from before. And if we need additional memory on top, we'll hot add. And so a quick visualization of this. So we have 0, we have the startup memory, and we have the maximum memory. So all of a sudden, it's Black Friday in America. Thousands of shoppers are coming on my web server. Let's hot add. Let's add some more memory to work that load. And then ballooning. All of a sudden, okay, shoppers have gone down. Let's go back to normal. And so the Linux VM still sees I have all of this memory allocated, but the ballooning has gone in and taken some of this memory and reallocated it back to the Hyper-V host and the guests running on that host. And then let's say, the following Monday comes up, and now a bunch of shoppers are back at it again. Well, we can add load back through ballooning as well. So live virtual machine backup. This is a full backup of a Linux VM without any interrupting operations. So we don't stop whatever you're doing and say, okay, live backup in progress, and cancel whatever task was at hand. The backup is file system consistent. It is not application consistent. What happens is the file system freezes for 1 to 2 seconds. Doesn't interrupt what you're doing, though. We flush whatever is going on, and then a live backup is in progress, and we take whatever storage you have and put it in the backup storage you need it to be in. And so that's accomplished through Hyper-V and the LIS drivers. And so just kind of a quick visualization of this. You have the backup utility, which can be anything. It could be Windows Server backup utility. It could be data protection manager on the System Center front. It could be a third-party tool. As long as it's calling the Hyper-V backup API, it should work regardless. And so you have your Hyper-V host running Linux, and then split up in the Linux guest, we have the VSS daemon, we have the VSS driver in the kernel space, and we have the file system buffers. And so the one thing to note for VSS, right, volume shadow copy service on Windows, it notifies applications, hey, we're going to go for a backup, make sure to come along for the ride, and you get that application consistency on Windows. On the Linux side, we don't do that. There's no kind of similar style writer function in an application, so we're not application consistent. It's going to only be the file system. So that's why that star is there, where it's somewhat misnamed. We do not implement Windows VSS. And then you have Hyper-V storage, can be whatever storage you want with the guest VHD, and then the backup storage. So we'll go into my backup utility. I'll tell Hyper-V, hey, I want to back up this VM. It's going to call the same API for Windows Linux. And then Hyper-V is going to say, okay, it's a Linux VM. Tell the driver, the kernel space. He's going to go tell the daemon running in user space. And then the daemon is going to freeze the file system. It's going to flush in memory buffers. It's going to create a checkpoint, and then tell LIS to unfreeze. So between 3 and 4, 1 to 2 second pause. And then all of a sudden, 5 comes along. We've created a snapshot. And now we're starting to load that into your backup storage of choice. So you're going to, however long 5 to 6 takes, it could be a day or 2 days, hopefully much less than that, like 20 minutes. But doesn't matter. 1 to 2 seconds is the only pause you'll see from 3 to 4 where we freeze the file system. So the next feature is networking. So hot add, hot remove of a virtual NIC. This is a new feature in 2016. This is my favorite. You don't have to shut down to add a NIC. You don't have to shut down to remove a NIC. It is so simple, yet so valuable. It's also one of my favorite demos because it's so easy to show and so valuable again. Network throughput. So on the network side, we implemented VRSS, virtual receive side scaling, and VSSS, virtual send side scaling with various TCP offloads. So if you ran this before all these new features, what you would see is if you have a multi-core server, have a bunch of network traffic, it's going to get hammered, and you're going to see one CPU at 100% and your other guy is not doing any work at all. And one of the kind of benchmarks for iPerf3 we ran with 2 Hyper-V hosts with 8 vCPUs against a 10G Ethernet, saw 9.4 gigabytes per second throughput. gigabit per second throughput. And of course, everyone's now using 40G. We're seeing speeds around 30. And this translates into Azure as well. So in Azure, we're seeing around 30 as well, and continuing to improve here and continuing to improve in Azure for network throughput. So a quick demo of Linux and Hyper-V. Okay, so start off with dynamic memory. So if you haven't seen a Linux VM in Hyper-V, it's very boring because it looks just like Linux anywhere else. And so you can see here's Linux, here's kind of the serial bus startup. Let's log in. And let's do a watch free -m. So we'll watch the free memory there. And we can see, okay, we have 736. And then on the Hyper-V console, we're showing assigned memory of 692. That's okay, 32 megabytes of that is allocated to the frame buffer. So we're fine. And let's give this one a heavy load here. And let's run load dynamic disk. What this is going to do, it's going to load up a web server and just start hammering this VM with high load. And we'll start seeing, okay, here's the memory. I need more. Man, so many people are, look at these transactions per second. And you can see this number has grown to 1140. And if we look at the Hyper-V console, you can see that memory has grown accordingly as well. So let's go ahead and kill this load. So we've done hot add here and kill this load. And now that the load's gone, we'll start beginning ballooning and we'll start to see that memory fall. But we won't see it fall on the Linux OS. So over here, we'll continue to see 1140. Where the change will happen will be in the Hyper-V console side of things. But we'll hold off on that as it will take some time to happen. So in the meantime, so the NIC demo, my favorite one, let's log in. So let's do a watch ifconfig. So we have ETH0. And let's go here and add another network adapter. And we'll add it there. And we'll apply. And there it is. All good to go. But you know what, I changed my mind, I don't like it, so we'll remove it. And just like that, it's removed. So very simple, very useful. And then secure boot. So if you're familiar with 2012 R2 and you make a Gen 2 Linux VM, you'd have to come into the settings place and say, okay, when I go into this boot, I need to disable this. But we've made sure that all those signatures are signed with all our vendors. And so when I come in here and start, fingers crossed, it's going to check and say, hey, you don't have a rootkit, we'll start up. And it started a Pixie boot. And looks like we stopped the network one, and now it's loading up the OS. No controller found, that's fine. Doesn't find a keyboard. Dun, dun, dun. And there we go. Loaded up. Didn't have to disable secure boot. Okay, and then if we come back to this dynamic memory, we'll still see 1140 here because, of course, we don't have hot remove. Linux OS doesn't notice any of the memory being taken out from underneath it. But if we look in the Hyper-V console, we'll see 818 instead of the 1172 from before. So that's kind of the Hyper-V story. And now we'll switch gears here into the cloud, into the public cloud, Linux and FreeBSD in Azure. So who here is using Azure today? Okay, good amount of hands, good amount of hands. And how about Linux workloads in Azure? Okay, nice. I love it. So first we'll start off with ways to get Linux or FreeBSD images in Azure. Do I have to, hack the settings in order to get Linux there? Do I have to do X, Y, and Z to get Linux in Azure? No, you can get Linux through the Azure Marketplace. We offer a variety of images there, and we'll step through kind of the support structure and what Marketplace images are available there. Or you can upload custom images as well. So you can take your Linux workloads running on-prem, you can pile it into a VHD and then throw it up and have it running in Azure as fast as you can upload and Azure can ingress. So the first one of the marketplace is the Azure endorsed marketplace Linux images. So these are partner created and Microsoft tested. So we have a whole test unit that goes out and makes sure these images are running fantastic in Azure. And you have a bunch of people out there like Canonical, OpenLogic, Oracle that are doing their testing, and then they hand it off to us, and then we make sure that runs great as well. And so the customers who are running those Azure endorsed marketplace images can go and contact those Linux vendors and get support from there. And then, of course, Microsoft will support any Azure incidences as well. And then premium images. This is kind of a new one. This is where Microsoft will actually engage the Linux vendor on your behalf. If you have any problems whatsoever, contact Microsoft. Microsoft will go to, at this point we only have SLES, so we'll go to SUSE and say, hey, this customer is having this issue. So that's kind of a new image that's going up, and we have more coming soon. So we're working with partners to make sure we have additional premium images on the marketplace. And so instead of just the normal marketplace, we also have kind of the larger Azure marketplace that isn't Azure endorsed, but has a bunch of solution stacks and other vanilla OSs. So these are, you can see WordPress, you have Redis, you have New Relic, you have Oracle DB, you have SAP, you have Apache Tomcat, Cloudera, Puppet, you name it. You can go out there. These partners have gone out there and taken the base vanilla OS, added their applications on top, and now they're available for your consumption. And then lastly, we have this kind of community of VM Depot. And this is where you or I or anyone else can go out and upload their own images. And now anyone can go out and consume that content. And so you can put a whole solution stack. You could put a vanilla OS. You could say Anurag's Ubuntu image that he will always use forever. And you guys could go out and download that if I put that on VM Depot. And so Azure is an open cloud. I love to show this image. We have a bunch of Microsoft integrated tooling. We're working with, we have good partnerships with like Docker, with Hadoop. Hadoop's powering HD Insights. We have a bunch of operating systems, of course. You have Windows, Linux. Our management tools, we have Chef and Puppet. Chef integration with VM extensions. We have devices. I mean, this is, whoa. And then also the ecosystem provided. So if it can run on Linux, such as Ruby or whatever, it's going to run on Azure. You can run it in your workloads just as you would imagine on-prem in Azure. And you shouldn't expect any kind of crazy things to differ between your Linux OSs there. So when we talk about managing Azure, especially if you're coming from the Linux side of things, do I have to go to my Windows admin every time I want to spin up a new Azure VM? I don't have Silverlight on my Linux browser or my Mac browser. How do I go out and make sure that I'm going to get the best management? So we have the Azure CLI for those guys who love the command line, and that works across Windows, Mac, and Linux. And so you can go out and run that, and you have full Azure management. In fact, you have some additional things that some of the guys in the portal can't see. So if you have people who are using the portal and you want to show up, one-up them, you can use the CLI and look really cool. Of course, you have Azure PowerShell as well. And then the HTML5 portal. So if you have Silverlight and you are, if you can't run it on the browser, you have the HTML5 portal, which is one of the reasons why Azure is so awesome, because the portal is so great. So just a quick Linux and Azure demo. Okay. So how many of you are familiar with Docker? Nice, good show of hands here. So one of the things we did recently was we have a Docker container that also contains the Azure CLI. And so Docker containerizes all the requirements for an application and makes it very easily deployable and scalable. And we won't get too much into what Docker is, but for this presentation, I will show you the Azure CLI. And as a side note, it's using the new Docker container runtime. So what I'm doing here is I'm specifying a new Docker container. I'm mounting a specific file directory to another. I'm going to run it in an integrated terminal, and I'm going to use the Docker container image that's been published to the Docker Hub. Okay, and so now I'm running my container, and if I type in Azure, boom, I have the whole Azure command line at my disposal. And we have some nice graphics up there that I want to show. Yes. And so now I can also go in here and I can log in. For this one, I'll do a quick import. And so I've imported my publish settings. And now I can look at all the VMs running in this Azure subscription. So I can do an Azure VM list. It's going out. It's grabbing all the VMs. And we can see every VM that's running under the Open Source Technology Center, which is a good amount. You can see if they're deallocated, you can see their IP. But now the cool thing that you can show off to everyone else at home is you can run Azure VM image list. And this is going to include images that are not being shown in the portal. There's so many of them, right? It's every single image out there. And the cool piece here is if you pass it into a Ubuntu, this is grep is just looking for all the Ubuntu printed from that previous line. You can see the daily build. So Canonical out there is making sure that Ubuntu can run on Azure with their daily builds. You can actually grep for the Ubuntu daily builds and build a VM with the exact build that was verified that day. So you can always show that off as well. You can see. You can even go back a week if you really want as well. So that's kind of what the Azure CLI looks like. Quick demo there. So the Azure Linux agent. What is the Azure Linux agent? If you look in your RPM packages that are installed by default in your vanilla OS, or you look in your Debian packages that are installed by default on your OS, you're going to see this thing called the Azure Linux agent. It's built in Python, and it's required for every Linux and FreeBSD VM that's going to be running in Azure. And the reason is it's doing a lot of the heavy lifting with the Fabric controller and the VM. It's doing the provisioning. It's making sure that your host and username are exactly what you specified in the portal. It's doing all the SSH key stuff and disk management. It's going to manage your networking, so give you routes for DHCP, your networking interface names, kernel functions, your virtual non-uniform memory access, your SCSI timeouts. And then the cool one is you'll actually redirect console output to the serial port for debugging. So actually just announced a couple of hours ago, and I'm glad to announce it here as well, is that the serial port debugging can actually now be accessed without having to go and submit a support ticket. So you get to see all the startup stuff that you got to see from that secure boot startup. If you have a custom image and you upload it up into Azure and all of a sudden it's not working, it's not a great experience, now you can actually go out look and get that serial port debugging output without having to submit a support ticket. So useful if you're putting up custom images. And then lastly, it does VM extension handling. So it allows you to add kind of other capabilities on top if you have the Azure Linux agent installed. And so what are VM extensions? What's going on with these things? VM extensions are software components that are going to allow you to kind of add and enable these other functionalities atop a virtual machine. So a VM extension, for example, is Docker. You can go out and take the Docker VM extension and add it to your VM, and then you have Docker capabilities in your VM. You can do it with custom scripts. So if I have a script that's going out and installing a specific package, you can make that run for a specific VM. We do have restrictions on the version for the Azure Linux agent. You need the 2.06 version or greater there. And all Azure-endorsed marketplace Linux images have support for these VM extensions. So if you remember that list of the marketplace support style and others. And so what VM extensions do we have? So the current ones we have are the custom script. So you write anything, write a Bash script, write a Python script, and doesn't have to be tied to any specific language. Run that across whatever machine you want. You can use PowerShell to run these extensions. You can do it through the portal. I'll show a quick demo of doing it through the portal. VM access. So say you're like me and you're very forgetful. You forget your Azure password for your VM, potentially right before you're going to present in front of everyone. You can use the VM access extension and reset that password, reset that SSH key if that's been compromised. OS patching, this one allows you to specify cron jobs to run an apt-get update or a yum update, whatever package manager you're using there. And then we're continuing to build more and more. So we have this monitoring one that's kind of coming to full fruition soon that's going to allow you to get all the diagnostic data for debugging and troubleshooting, as well as a bunch of performance metrics that you might be used to on the System Center side of things as well. VM snapshot, so if you're familiar with Hyper-V, you can take a snapshot of your VM. Same thing in Azure, have an extension that allows you to do that. Very useful if you screw something up. VM encryption, this allows you to automate the encryption of storage volumes and then have a reconnection and authentication as well. So a quick demo here of VM extensions. Okay. So I have my Linux box here that's running in Azure. I'll go to the Azure portal, this internal portal. And how many of you have seen the new portal? Okay, most people? Okay, good, good, good. Well, if this is your first time, it's a whole new world. It's a great world to be in. Definitely recommend you guys go to portal.azure. And so in here, I can go ahead and navigate to my virtual machines. So this also works with the classic ones. It doesn't have to be spun up in the new portal. And here's the same VM I had SSH connection into. And all I do if I want to add a VM extension, I go into Settings, and I go over here into Extensions. So I already have the diagnostic extension enabled. But what I'm also going to do is add a brand new one. I'm going to add custom script for Linux. And so some of the other ones, we have partner ones with Datadog and Chef. We have, Microsoft ones as well, which is this custom script. We have Docker, etc. So I'll go ahead and create a custom script for Linux. And I'll take a script file. So the script file I'm going to take executes this. It's a very simple script. Goes out and says, hey, apt-get, go install Apache 2. And don't prompt me yes or no, just say yes. And of course, I also have sudo authentication enabled as well. So I'll go ahead and select that file, which is install Apache. If I had arguments for this shell script, I could add those here. In this case, I do not. So I'll go ahead and click OK. So now it's going to go ahead and add this extension to the virtual machine. It's going to go out, start interfacing with the Azure Linux agent, and it'll actually return status on whether it failed or succeeded and give me the standard out of whatever that command was. So here it's adding the extension. We'll give this a little bit of time. In the meantime, if we look here, hopefully it doesn't install before I... Yeah, so if we do a dpackage list that lists every single package installed, and then I do a grep for Apache 2, see if any Apache 2 packages are installed, we get nothing. We get zip. And now, as soon as this extension is enabled, it'll go out, install the Apache 2 packages, and then when we run that exact command again, we'll see the Apache 2 things. Okay, perfect. So we have a successful added extension. Let's go ahead and look at what that looks like. So % complete 100, success, great. Let's go over here, and fingers crossed. Oh, boo, boo, boo. Okay. Well, that's an example of how custom script doesn't work sometimes. Maybe I put in the wrong machine. I doubt it, but yeah. So that's a quick example of the Azure Linux agent and the VM extensions it offers, and custom script not working. So in summary, Linux is a core business for Microsoft. We're committed to this. My team name has Open Source Technology Center in it. We're getting serious about the naming as well. It's a part of every day of work. I make sure we're delivering a good Linux story on Hyper-V, on Azure, in terms of management as well. Hyper-V and Azure are the definitive platforms if you want to run Windows and Linux workloads. Windows, of course, we're doing well because we're Microsoft, and Linux we're doing well as well because we're playing to the community and we're making sure that we're catering to what customers need. And the support there is continuing to grow every day. We're continuing to add new VM extensions, add new capabilities in terms of management, make sure your network throughput is increasing, and we're making sure you're having the best experience when you run Linux and FreeBSD in these platforms. So here's some related sessions. Please grab some buttons and stickers here as well. Any questions about Linux, Hyper-V, Azure? On AMD 64, yes. So if you have, yeah. Yes, that's supported as well. So as long as the virtualization is running atop that, it's good, yeah.
Is it supported for hyper-partitioning for Oracle workloads in case you want to pick your licensing in Hyper-V?
One more time?
For instance, Oracle VM
Yeah.
is used a lot because the licensing
Got it.
advantages that you have. Will Hyper-V have the same for Oracle workloads?
So is the question, just one more time, so Oracle VMs running atop Hyper-V?
Oracle VM is a supported platform for hyper-partitioning, pinning CPUs to the VMs. Hyper-V does support that for
Yes, yes, you can have multi, if the question is multi CPUs on Linux VMs, absolutely. Azure Linux on Hyper-V, absolutely.
Is Microsoft working along with Oracle to get a better license deal?
I don't believe there's any kind of licensing partnership there, but there is a partnership in terms of getting Oracle running on Hyper-V and Azure, as well as kind of their other solution stacks like WebLogic, Oracle DB in Azure. Yep. Any other questions? Yes.
So I've got a Linux box on Azure at the moment.
Yes.
What kind of tools do you use to RDP onto that box? Because I notice the Azure interface itself doesn't do it for you. I'm just wondering what you would use.
So there's two things you can use that are kind of cool that you might want to go try out. One thing I use is MobXterb. You can always use PuTTY, any other SSH client. But there's actually a new SSH web console that uses a Java applet. That's brand new. It's in preview. You can go try that out as well. Any other questions about Linux, Linux management, Linux in Hyper-V, Linux in Azure? I know we have. What was that? Red Hat support. Red Hat support in Azure. Great question. Question I get a lot. We are working on it. Yep. Yep. And also another thing, just to kind of extend out this, we're always looking for feedback from the product group in terms of what features we need to go tackle next. We're having discussions on an ongoing kind of weekly, monthly basis with customers such as yourselves. If any of you are interested in kind of attending any of these weekly or monthly sessions with the product group, whether it's for management or it's for Hyper-V or Azure, definitely come up afterwards, and I'd love to grab your information as well. Okay, I think that's all I have. I'll try and get custom script for Linux to work if you want to stick around. Thank you very much.